Hello everyone. So today I'm going to work on a way to smooth out this trail generation system and making a permanent deformation on the grass landscape for both player and also enemy NPCs as well. Here, as you can see in this demonstration. So the trail consists of two parts. One is just a temporary deformation created by the trail blueprint that we created before, and the other part leaves a permanent deformation. Here you can see on the places where the character walked on, the deformation stays there, and this is based on distance fields, so no runtime virtual textures are used for the deformation here. And I have already worked on my some components in this system in previous tutorials. So today we are going to look into how to make the permanent component of this trail to affect the bending of grass blades in a smoother way rather than just snapping them, because we were using instances of instanced static meshes, and I was adding mesh instances to create the bending on the grass. But as the instances are added with the fixed scale, we could see some instance bending or snapping on grass at first, but now as you can see here, that bending is smoothed out because we are using custom data, per instance custom data, to drive scaling of the instances of static meshes to achieve this smooth bending. So I will explain everything in detail in the tutorial. So yeah, but this is the end result that we are going to have today. Okay, so before we get started, let me remind you that you can download the project files of this project and all other thousands of projects that I have done in my channel from my Patreon page. Once you become a member, you can access everything without any limits. And also I'll leave a link to the to the full playlist that I have covered everything that you see in this tutorial. So yeah, now let's get back to today's episode. So right, to explain the problem, let me open my character, and this is this function place footstep. This is where I place instances of meshes to deform grass or whatever the landscape that we have. So here I am using this ISM footstep. Let's find references. Here I'll add an option to show debug footstep objects. I'll make it false by default, but if it is true, set material, give a selection using this. If it is false, I'll use M masked. If it is true, I'll use, do I have a default one? Okay, this one, copy. I can't paste it. Select it here. Make this, no need to make it public. But if I now enable this visibility, you can see the objects that represent these are the objects that affect the grass blades. So as you can see, instead of making them appear instantly, if I initially spawn them small and then enlarge them, I think we should be able to achieve uh, some enlargement, some smooth bending on the grass plates. Okay, so to test this, yeah, first let me go here. Let me duplicate this. I'll call this debug. Okay, so here I'll set the opacity to 1. Oh, it's closing my other screen. Opacity to 1. Okay, now I'll use that material. Oh, not for that, this one. So we can test the enlarging effect. Okay, now here we can, okay, now here we can do this. We can get cost per instance custom data. And here let's use the index 0, default value also 0, and then I'll get time. So what I'm planning to do is I'm gonna inject per instance data value that represents the time that this instance of the static mesh is spawned, and then using this time I'm gonna make it enlarge over time. So we can subtract the spawn time. This will represent the spawn time. We need to set this as we spawn the instance, and then to get some, to slow down the effect, we can divide this. Let's promote this to a parameter in large time. Let's try 2, and I'll clamp the value between 0 and 1, and then we can multiply this with some value. Let's promote this also to a parameter. Let's call it in large scale, maybe 10. We can decide this later and fine tune. So I'm gonna give this, based on this value, I'm gonna give a word position offset to the mesh. So we can use vertex normal so that we can push the boundaries along the normals and multiply it with this value. Right. So do I see anything different here? Maybe not, because we don't have anything as of now yet here. So now let's go here. First, into this instance static mesh, we need to set here under custom, under instances, you have to set number of custom data floats. I'll make it be 1 because I need only 1. And then here, put steps, custom data, set custom data value, and index is 0. Oh no, instance index is this instance, and the custom data index is 0. So value time since, get time since creation, it's in seconds. I'll inject that. Do I need to make this dirty? Maybe I do. I'm not sure. Let's just enable it and disable it and see. Right. Is that all? Yeah, see? Now these objects are getting enlarged, but the initial scale is already too much. So maybe we can Here is the scale. Let's add a multiplier here. Plot scale. But it should not be 0. Let's try point 1. Okay, that's not enough. Let's make this point 2, and here enlarge time. Let's reduce to 1, and maybe this 50. That's better. Okay, now we can copy this part. Or can I? The function. M instance M large. Right, now I'll use the same function here in the masked material. And I'll disable the debug mode. Let's see. See, now we don't see that snapping thing. We can see the path is generated smoothly. And another thing is, maybe now that we have a permanent way of leaving the trail, we can get rid of this the other method that we had to generate the trail. But okay, so what we can do is, here we have this X scale of the placed object. Let me enable debug, show debug objects, and let's try something like 3, 2, 4. Now we should see that now these are big enough to have a consistent path. See? So now if I disable this, I should see a continuous path even after the temporary trail is vanished. See? This is good. And if you are running, of course you are going to see some discontinuity, but that's reasonable, I think. If the character is running, footsteps are further apart, so I guess that's okay. But if you want, you can further increase the scale, y scale, x scale of the placed footstep objects, so you can have, even if the characters are running, you can have a consistent path. And if you run into the limits of the footstep objects, maybe you can start recycling them. So the first one move to the last point, something like that. Sort of like a object pooling, but that may not be necessary in this case. Anyway, now let me create a system to enable or disable this trail. So pp trail objects. Let's see simple construction. Yeah. Let's add another boolean. Trail enabled. It enabled by default. And get branch. If it is enabled, I will create objects. And also tick enabled. Yeah, set actor tick enabled if trail is enabled. Otherwise, it will be disabled. And now here we have trail enabled. I'll disable that, so we will not have the trail coming from that part. We will only have the trail that is coming from the objects that is placed based on footsteps. So it's up to you. If you want that system as well, you can leave that enabled. One more thing, let me just check how it looks on a steep land. Well, it looks fine. Okay, now just to demonstrate that this same method would work on NPC characters or any other character in the world as well, let's set up a simple free roaming function for the character. First, I'll add a nav mesh. I don't think I have a nav mesh here. I don't. Okay. So maybe I should do this off screen. Oh, okay. Nav mesh added. Now we disable the visibility of that. And here in the event graph, I add a custom event free roam, and I move to one is serve, destination is random reachable point in radius, origin we can use get actor location, radius 5000, distance 100. On success I'll call zero. On fail I'll have a delay and again call free roam. In the begin play, here I have a branch display code. If false, I'll call wrong. Now this other character should also start moving. Yeah, see, it's moving, and that character also leaving a trail. Oh wait, I'm colliding with the objects left by the other character. I must have forgot to disable collision. Yep, no collision. All good. All right, so here is the final demonstration. You can see all the characters are leaving a trail, even the one in the distance. And yeah, that's all I'm gonna do for this episode. So thanks for watching. As always, updated project files will be available for download in the Patreon page. Link would be in the description below. And let me know if you have any questions in the comments. See you in another episode. Goodbye.